Welcome to the deep dive. We take these really complex moments from elite sports and try to unpack them. You know, the strategy, the tech, the human side.
Yeah, absolutely.
And today, we are jumping right into the pressure cooker of Formula One. We're focusing on a pretty dramatic incident recently. A top driver, Hamilton, experiencing a complete brake failure during a race.
Mm-hmm. And it's more than just, a part failing. This is actually a fantastic case study. It lets us really peek behind the curtain.
How so?
Well, we get to look at the strategy that kind of set the scene for it, how the pit wall uses that incredibly detailed telemetry, and importantly, the ethics involved when a driver's pushing a car that's fundamentally broken.
Right. Big risks, big data. So we've got a few key questions for this deep dive. Firstly, how did the team's own strategy maybe push that component too hard?
The crucial question.
And then what exactly were the engineers seeing? What data told them, uh-oh, the brakes are going?
The smoking gun, so to speak.
Exactly. And maybe the most intriguing bit,
Mm-hmm.
what does the driver actually saying no brakes over the radio tell us about F1 tactics? Is it just panic or something more?
Oh, there's always something more with radio messages.
Okay, let's start with the driver's headspace then. Because our research suggests he's generally been more tactical this year, maybe not always showing that ultimate pace we've seen, often behind teammates or key rivals.
Yeah, and that's really important context. It ties into this whole psychology of top-tier racers. There's this idea that they're real superpower, that extra gear, that absolute razor's edge speed.
A magic lab.
Exactly. That only really comes out when they smell blood, when the car feels like it can genuinely win, or they're in a proper scrap for the lead.
Ah, okay, so if the car is maybe only good enough for 5th or 6th, they're still pushing hard, obviously.
Oh, absolutely. They're driving flat out to the car's limit.
But they're not dipping into that, final reserve of risk, that extra couple of percent.
Precisely. They're executing smart, calculated races. Think back to some of Hamilton's legendary wet drives. Turkey, Brazil. The win was on. That's when the superpower engages. Fighting for P5, it's professional resource management. You can serve that ultimate risk level. It's not lack of trying, it's calculation.
And even driving within those limits, the strategy just before the failure was, pretty brilliant, wasn't it?
Oh, it was textbook, beautifully executed.
He was trying to build that gap, right? Enough for a free pit stop targeting Antonelli just ahead.
Yep, the pit wall saw the window, gave the call, and he delivered exactly the pace needed. We're talking laps about 3 seconds faster than his normal race pace. Just bang, bang, bang.
Wow.
The strategy itself was absolutely spot on. It failed because the car gave up. The mechanical side couldn't hold up its end of the bargain, which leads us neatly into the failure itself.
Right, the mechanical mystery. Let's talk location first. Singapore. Everyone knows Singapore.
A nightmare for cars.
Street circuit, incredibly tough on brakes. You've got the heat, the humidity, almost no long straights for cooling.
Very little airflow.
Yeah, just constant heavy braking zone, stop, start, it just cooks the systems.
It's a massive stress multiplier, definitely. But we need to be clear about the type of failure here. If this was just the brakes getting too hot, a purely thermal issue.
The driver manages.
A driver of Hamilton's experience, absolutely. He'd back off a touch, maybe lose a second a lap, pump the pedal, try to get some air through, manage the temperatures down. He'd lose track position, sure, but the brakes wouldn't just disappear.
But they did just disappear. He didn't just slow down. The message was no brakes and the time loss. You mentioned 30 seconds a lap, maybe more.
Yeah, staggering losses in those last 2 laps. That screams total system failure. Not overheating. We're talking like a potential hydraulic leak, maybe a seal just completely went, or possibly vapor lock in the fluid, something catastrophic.
Okay, so from working fine to slightly iffy to absolutely nothing in just 2 laps.
Exactly. Which brings up a slightly more critical point about the team setup, a bit of professional skepticism maybe. We know the strategy required him to push flat out, those qualifying style laps, 3 seconds quicker than usual for several laps straight.
To build the gap for the pit stop.
Right. So the question becomes, was the car's cooling configuration, specifically the size and design of the brake ducts, actually capable of handling that kind of sustained peak load?
So maybe they'd set the car up for, say, maximum aerodynamic efficiency, assuming normal race pace cooling would be just about okay.
Exactly. Trading off a bit of cooling margin for maybe better downforce or less drag.
And then the strategy demanded performance that pushed the cooling way beyond what that setup could handle.
That's the potential scenario. Engineers are always pushing that limit, finding that edge. If you trim too much cooling for aero gain, and then your driver executes a perfect but very demanding strategic phase, boom, you risk overloading the system.
That's the tightrope walk you mentioned. Performance versus reliability.
Always. Constantly balancing those two.
Okay, so let's shift perspective to the pit wall. The engineers staring at screens, they can't physically see the brakes, but they have the data streams. How do they actually track brake health? How do they know a failure like this is coming?
Right, this is where it gets really interesting. The key tool, the main diagnostic, is something called brake stiffness telemetry.
Brake stiffness.
That's
Looks technical.
It sounds it, but the concept is actually pretty straightforward. Imagine a simple graph. It tracks the relationship between two things. The brake pressure the driver is applying through the pedal.
How hard they're pushing.
Exactly. Versus the displacement, how far the pedal actually travels down towards the floor.
Okay, pressure versus travel distance. Got it.
Now, in a healthy system, no leaks, no air bubbles in the fluid, that relationship is really consistent. You push the pedal just a little bit, and the pressure ramps up very quickly. It feels stiff. On the graph, that's a steep, consistent line or slope.
Makes sense, a firm pedal.
Yeah, but now watch that graph lap after lap. When a failure starts to develop, maybe a tiny fluid leak, or the fluid's getting so hot it's starting to vaporize.
Problems brewing.
Right. The driver finds they have to push the pedal further down to get the same amount of braking force, the same pressure reading. The travel distance increases for the same pressure.
So the pedal starts feeling mushy.
Yeah.
Going closer to the floor.
Exactly. And on that graph, the slope changes. It becomes shallower, less steep. Engineers see those data points plotting, lap by lap. They see that slope changing. They know the stiffness is degrading. They know a major failure is becoming more and more likely, often before the driver even radios in a serious problem.
And they have other data too, right? Not just stiffness.
Oh, yeah. They've got multiple temperature sensors on the discs, the calipers. Crucially, they often have an infrared sensor pointing right at the caliper assembly, giving a direct surface temperature reading. You combine the falling stiffness with maybe rising temps.
The picture becomes very clear on their screens.
Very clear. They can see the failure progressing, almost in slow motion sometimes.
Okay, but this leads to the really tense question. If the telemetry is that clear, if the engineers could see the stiffness falling off a cliff, the pedal travel increasing, why didn't they tell him? Why not yell, box, box, critical issue, or even tell him to retire the car immediately?
That's the million-dollar question, isn't it?
They let him circulate for 2 whole laps, losing huge chunks of time, with what sounds like a ticking time bomb under his foot, it seems. Risky. And hey, just a quick pause here. For those of you watching us on the Drifter Zone YouTube channel, welcome. Glad to have you with us. If you're finding this deep dive into F1 tech and tactics interesting, do us a favor and hit that subscribe button below. We do these breakdowns regularly, really getting into the data and strategy. Okay, back to it.
Right, that decision to let him continue. Let's talk about the ethics and the risk management there. Is driving with failing brakes dangerous? Of course. It's probably the single worst failure you can have, losing control of deceleration.
Yeah, fundamentally dangerous.
But these drivers are incredibly skilled and conditioned professionals. Think about driving with a slow puncture. They're trained to manage compromised machinery, to bring it home or back to the pits if the risk seems, well, manageable.
And the key thing here was maybe the track position. He wasn't surrounded by other cars.
That was likely a huge factor in the calculation. In those final 2 laps, he was basically circulating alone, so the team weighs it up. Immense danger, yes. But it's a professional driver, isolated on track, race almost over. The calculation might be the professional obligation is to try and finish, get any result, any data if the immediate risk of collision is low.
So balancing safety against professionalism, points, data.
All of the above. It's a hugely difficult call made in seconds under immense pressure. They likely decided the risk for those last couple of kilometers was just acceptable.
Okay, that makes some sense, even if it feels uncomfortable. Which brings us to the radio call itself, the driver explicitly saying, I have no brakes. You heard some people calling that tactically naive, almost a rookie move.
Yeah, you do hear that perspective, and it comes down to tactical awareness of who's listening.
Meaning the FIA.
Exactly. The FIA monitors all the team radio. If a driver comes on and states unequivocally, "I have no brakes," confirming a major safety critical system failure, that gives the race director clear justification to immediately throw the orange and black flag.
The meatball flag forces you to pit for repairs or retire.
Right. So from a purely tactical standpoint, explicitly confirming such a dangerous failure might be seen as handing the FIA the reason to end your race prematurely. You perhaps don't want to give them that definitive, undeniable statement if you're trying to limp home.
So if it's tactically risky, why do it? Why not use coded language or just say brake pedal long or feeling something strange with the brakes?
Because the radio isn't just for informing your team, it's also a weapon. It's used for, well, tactical communication and even psychological warfare.
How so?
Teams and drivers. Fernando Alonso is perhaps the absolute master of this. They use the radio very deliberately. They will sometimes explicitly complain, maybe even slightly exaggerate an issue.
Okay, but what's the goal?
Couple of main goals, usually. First, making sure the FIA hears the complaint loud and clear. It puts your issue on their radar, forces them to maybe look into it, potentially leading to that under investigation notice popping up on screen. That can pressure rivals or establish grounds for a later protest.
Using the broadcast to influence the officials.
Precisely. And second, remember that selected radio messages are broadcast globally, to the media, to us, to you listening. By saying, "I have no brakes," Hamilton instantly frames the narrative.
Becomes about the brake failure.
Exactly. The story is car failure robs driver, not driver error or strategic misstep. It protects the driver, focuses blame on the machinery, and manages the public relations fallout. It maximizes the sort of narrative value of the failure for the team.
Wow. So even in what sounds like a moment of pure distress, I have no brakes, there's likely a layer of strategic calculation underneath, maximizing every resource, even a failure.
In F1, pretty much every action, every word broadcast has a potential tactical angle. It's an incredibly high-stakes, deeply strategic environment. Ruthless, really.
That really puts it in perspective. Okay, let's wrap this up. So the key takeaways for everyone listening. First, that constant tension, right, between brilliant strategy execution and the sheer mechanical risk involved.
Yep, push too hard and things break.
Second, the power of that telemetry, specifically brake stiffness, that subtle graph telling the engineers a huge story long before the pedal hits the floor.
Incredible diagnostic tool.
And finally, the radio. Not just communication, but tactical warfare. Every message potentially calculated to influence officials or shape the story.
Absolutely. It just highlights that elite racing is constant critical decision-making. Driver, pit wall, balancing safety, professionalism, tactics, all under this intense global spotlight. It's never, ever just about who's fastest on the day.
Well, thank you for joining us on this deep dive. Hope you found that as fascinating as we did. And again, if you are watching on the Director's Zone channel, please do hit subscribe. We've got plenty more analysis like this coming up, and you can check out our previous deep dives too.
And just before we sign off, here's that final thought we like to leave you with. Something to chew on. Given how much detailed telemetry the pit wall has, seeing that brake system degrading in real time, how much responsibility should the team ultimately carry for letting the driver continue those last laps, rather than calling him in immediately for safety? Where does that line fall? Something to think about next time you see a car limping home.